let's do another science experiment. Today and tomorrow we'll be working with yeast. I have this Costco-sized bag of yeast here that we'll be experimenting with, and this Erlenmeyer flask, which for those of you at home, you probably don't have this, so we'll be doing this experiment together as I work through it with your instructions. But basically, well, some of you saw this last year, I think, in Dr. Stringham's class. And while you know what's going to happen, the way that we're thinking about it and what we're learning from it is completely different. So we're going to be doing it again in a different way. So the basic setup, and this is how I set it up at the beginning of class that you saw, is I'm going to take 1 teaspoon of yeast and put it in here like this. I've got this giant tub of sugar. I'm going to do 2 teaspoons of sugar. 1, 2. And then in the demonstration I showed you in class, I used 100 milliliters of warm water. This water isn't warm, but you get the idea. We can have different temperatures of water. I have microwaves in here, I have stove tops, I have a refrigerator and a freezer, so you have access to different temperatures if that's something you're interested in finding out about yeast respiration. And then just a gentle stir it all together. And the reason we use this flask is so that we can put a balloon on top to capture the products of the respiration process, which is, of course, carbon dioxide. So eventually, this balloon, like we saw in class, will slowly start to inflate, and you'll be able to measure how big the balloon is, which is sort of a way to measure how much carbon dioxide is being produced. So you'll wrap the string around the balloon, and then stretch out the string and measure it with a ruler. So that's the basic setup here, and I want you to experiment with yeast respiration in whatever way you'd like. So here's our experiment. Here's where the video will be. This is where you and your group will design your own experiment. So I said up here, the purpose of this experiment is to determine how the blank, the independent variable that you choose, affects the blank, the dependent variable. That's the thing that you're measuring. And I put some questions on the side here for you to think about. What is the purpose of your experiment? Think about the variables that you might want to test, your group might want to test from our class yeast experiment. Here are some things that you could change, but remember, in a good science experiment, you should only choose one of these things. It's the independent variable. If you change multiple of these things, you're not going to know if the outcome was because of that one thing or the other. So here are some examples, and if you can come up with something other than this, then by all means do that. You could use 3 flasks and in each one change the temperature of the water. You could change the amount of yeast that you used. You could change the amount of sugar that you add. You could change the type or amount of liquid. So maybe instead of using water, use some other sort of liquid. I also have different types of sugar. I have brown sugar, powdered sugar. So whatever you want to change, that's up to you and your group. Once you figure that out, you'll fill out all of these boxes here. Then we need to design our data table before you do the experiment. So to design a data table, well, we talked a lot about this during class. If you don't like this one or can't edit it enough, you can just delete it, go to Insert, and then insert your own data table, whatever size you'd like. Once you have the data table complete, we're going to start our experiment tomorrow, Tuesday. When you're done with your experiment, and the experiment should take a good chunk of class because remember it takes like 30 to 40 minutes to do the experiment, you can write up your conclusion and answer a few questions about the respiration equation. So remember, we're taking sugar and oxygen from the air or whatever's in that flask when we start the experiment. Those things are breaking apart. It's a chemical reaction, breaking apart and recombining to form carbon dioxide, which is filling up the balloon, cough, and the water, which just kind of stays. It's hard to see because it mixes in with all the other water. So that's the experiment. Let's get started on it. If you have any questions, let me know.